All right, so I'm looking at the spec sheet for the Avenview FO-DVI-1000M-EMIX.
Mm-hmm.
And I had to be honest, my eyes went, well, they straight to the price tag.
Yeah, it's pretty hard to miss that one.
I mean, $1,465 for what looks, at a quick glance like a simple BVI extender.
It looks that way, yeah.
So before we even get into the tech, you've got to justify that number.
Yeah.
Why are we doing a deep dive on a cable system that costs more than my laptop?
Because it solves a physics problem, a really fundamental one that standard copper cables just can't handle.
A physics problem.
It's all about distance. You go buy a regular DVI cable, you're lucky to get a clean signal at, what, 5 meters? Maybe 10 if you really push it?
Oh yeah, you get the sparklies, the digital snow,
Yeah.
or the screen just cuts out entirely.
Exactly. That's just electrical resistance killing the signal. But this Avenview unit, it isn't pushing electricity down a copper wire.
It's using light.
It's converting those pixels into light and shooting them down a fiber optic strand. And that's how they get the 1000M in the model name.
1,000 meters, which is what, 3,300 feet?
Over half a mile.
Okay, that is impressive. But I did see a little catch in the documentation.
Ah, yes.
That 1,000 meter range is only for a 1280 by 1024 resolution. If you want the full WXGA 1920 by 1200, the range drops.
It drops to 500 meters, true. But 500 meters is still over 1,600 feet.
That's a fair point.
I mean, try running a standard cable that far. It's just not possible without a ton of signal boosters. This does it with a single SC-type multi-mode fiber strand.
Okay, let's pause on that. A single strand. Usually DVI needs a lot of bandwidth, right? You've got red, green, blue, plus the clock signal, keeping it all in sync.
Mm-hmm.
How do you possibly cram all of that down one tiny thread of glass?
That's the real magic here. It's called optical multiplexing. Think of it like a highway. Instead of building 4 separate roads for red, green, blue, and clock,
You just put them all in one super fast lane.
a lane moving at the speed of light. It makes the installation so much simpler. You only have to run one tiny, flexible cable.
But just sending the video is like only half the problem, isn't it?
It is.
Let's talk about the EMIX part of the name. The docs make a big deal about self-detecting EDID.
And they should. This is actually where most of the cheaper extenders completely fail. EDID, Extended Display Identification Data.
The digital handshake.
The digital handshake, exactly. It's the monitor telling your computer, hey, I'm a Dell and I can do 1080p.
And if the computer doesn't hear that,
It just gives you a black screen. It assumes nothing is connected. So this Avenview device, it records that handshake from the monitor and stores it in the transmitter unit.
so even if the monitor is half a mile away,
The transmitter basically pretends to be the monitor. It tricks the computer into thinking the display is plugged right in.
it's ghosting the monitor to keep the PC happy.
That's a good way to put it. And that stability brings us to the other big justification for the price: EMI shielding.
Electromagnetic interference.
Right. Think about where you'd actually need a cable this long. We're talking factories, hospitals, maybe power plants, places with huge electrically noisy equipment.
Like MRI machines or generators.
Incredibly noisy. Copper cables are basically giant antennas. They pick up all that interference and your video gets garbled.
But fiber is just glass.
And glass doesn't care about magnetism. You could run this cable right next to a high voltage line and the signal would be, well, perfect.
That completely explains the medical and military applications they mentioned. You can't have a surgeon's display flickering.
Precisely. It also supports HDCP 1.1 for protected content and 12-bit deep color. It's not just sending a signal, it's sending a pristine one.
And what's wild is that the hardware itself is tiny. I mean, the transmitter and receiver units are smaller than a deck of cards.
Yeah, about 2.4 inches long. It's a great example of form factor versus function. The physical box is tiny, but what it can do is huge.
And for the price, you get the power supply and a 3-year warranty.
Right, it's a full professional kit.
So, to sum it all up, we have a tiny device that turns video into light, fakes a monitor's handshake, ignores massive electrical interference, and fires the data half a mile down a single strand of glass.
That pretty much covers it, and it leaves you with a final thought to chew on.
Go on.
We all spend so much time obsessing over screen resolution or the speed of our graphics cards, but we almost never think about the invisible infrastructure, the literal beams of light that make it possible for the image to even get from point A to point B. Sometimes the most critical piece of technology is the one that's designed to be completely invisible.